Hello everyone, I'm Siddharthan. So far, we have completed about 6 modules in our hands-on machine learning course, and this is the seventh module. And this seventh module is all about building machine learning models from scratch. So every week, I will be posting videos about one particular machine learning model, and there will be 3 videos for each machine learning model. So the first video will be on understanding the intuition behind a machine learning model, and the second video will be on understanding the math behind the model, and in third video, based on this understanding, we will try to build a model from scratch in Python. Okay, so this will be the structure for our course moving on. So in today's video, we are going to understand what is the intuition behind a linear regression model. Okay, so before getting started, in case you are watching my videos for the first time, in this YouTube channel, I'm making a hands-on machine learning course. And if you want to learn this course from the beginning, I'll give the link of my course playlist in the description of this video, and you can check that out. With that being said, let's get started with today's video. So before going into linear regression, I'll just give you a quick recap on how does a machine learning model works. So when it comes to machine learning, we have two main things attached to it, two main pillars that supports machine learning. One is the data, and the second one is the machine learning model. So what does a machine learning model does is we feed it with lots of data, and this particular machine learning model will try to learn from this data. So learn in the sense it tries to find the pattern present in this data. So based on this understanding, or based on this learning that the model has done, if we give new data, it can try to predict new values. Let's say, for example, we want a machine learning model to find the blood sugar level of a person. So in that case, what we will do is we will take a suitable machine learning model and we will train this model with lots of data related to diabetes. Okay, so once the model has learned from this data, if you give a new set of data, it can find what is the blood sugar level of a person based on some medical parameters. Okay, so this is how machine learning works. So there is a machine learning model and we feed this model a lots of data and it tries to learn this data. Okay, so this is how every model works. And now let's try to understand how does a linear regression model works. So let's try to understand this with an example. Let's say that we have a set of data. So we have totally 5 data points in this case. And in this case, we have the experience in years. Let's say that there is a software engineering role. And let's say that we have 5 people. And we have the data as the number of years of experience for each person. So totally we have 5 people and their salary based on their years of experience. Okay. So a person with a 0 years of experience. So this person can be a fresher, and the salary he makes is about 2 lakhs or 200,000 rupees per year. Okay, so for a software engineer role. So there is another software engineer and he has about 2 years of experience and he makes a salary, or he makes an annual income of about 4 lakhs or 400,000. And a person with 4 years of experience makes a salary of about 800,000 or 8 lakhs. And a person with 5 years of experience make a salary of about 10 lakhs. And a person with 6 years of experience make a salary of about 12,000. Okay, so this is the data set that we have, a very small data set. And based on this data set, based on this particular data, we need to find what would be the salary of a person with 3 years of experience. Okay, so we have a set of data, and based on this data, we need to find this particular answer. So what is the salary that a person makes if he has 3 years of experience? So how we can find this particular answer? Think about this. So we can use a graphical method in order to find this answer. So let's try to draw a graph, and let's try to plot these data points. So we have two axes, x-axis and the y-axis. And in the x-axis, we are taking the years of experience. Okay, so number of years of experience for a particular person. And in y-axis, we have salary of the person. So the annual salary of a person in rupees. Okay, so here we have a 0 years of experience, 1 year of experience, 2 years, 3 years, and so on up to 7 years. And here we have the salary of the person as 2 lakhs, 4 lakhs, 6 lakhs, etc. So in the x-axis the unit is 1 year, and in y-axis the unit is like one unit is equal to 200,000 or 2 lakhs. Okay, so the value increases by 2 lakhs. So this is the graph that we have, and we try to plot this particular data. So a person with a 0 years of experience make 2 lakh rupees salary, right? So if we try to plot this, we will get the plot here. So 0, the x-axis value is 0 and the y-axis value is 200,000. And the second data point is 2 years of experience, and the salary he makes is about 400,000 or 4 lakhs. So similarly, we have 4 years of experience and 8 lakh salary, and 5 years of experience, 10 lakh of salary, and finally 6 years of experience and 12 lakh salary. Okay, so the annual income. So this is the data points that we have, and we have plotted these data points in a graph. Now we need to try to fit this data to a particular curve or a particular model. So if you look at this plot, we can say that there is a linear relationship between x and y. Okay, so the x value and y value. That means if the value of x increases, the value of y also increases. So it is not the case where at a point the value increases and then it decreases. So there is no randomness here. So there is only an increase in the value. When the x value increases, the y value also increases, and there is no other trend. So we just have only one trend, that if the years of experience increases, the salary also increases. So for this particular case, we can fit all these data points in a simple straight line. So if you try to find a best fit for this particular data points, it will be something like this. So we cannot draw a line which fits through all the data points. So it is not possible to draw a line which fits through all the data points, because this is kind of an outlier. So this is not an outlier exactly, but this data points is kind of different from these data points, and this is the best line that could fit all these data points, right? Because these data points are closer to this line. So totally we have about five data points, and four out of these five data points are closer to this line, except this second data point. Okay, so this is the line that fits this data. Now what we can do is, so we know that we need to find what is the salary made by a person with 3 years of experience. Now we can come to this x-axis, and we know that this is the number of years of experience. So we need to try to see where this point meets in the y-axis. So I'll just make a dotted line here. So this is the person with 3 years of experience, and based on this data, we got this straight line which fit through all these data points. And for a person with 3 years of experience, so this is the point where it is meeting the line, right? So if you find the corresponding y value, it will be looking something like this. So this value would be around 6,50,000 per year. Okay. So from this, we can conclude that based on this data, we can say that a person with 3 years of experience will make a salary of about 6,50,000. Okay, so this is the interesting insight that we are getting. So what we are trying to do is we are trying to plot the data in a graph, and we are trying to find a line or a model which could fit through all these data points, and then we are giving an x-axis value. So now if you give a x value, you can find the corresponding y value. Similarly, let's say that there is a person who is making a salary of about 14 lakh rupees per year. So in that case, we can try to join this, y-axis or y value to this particular line, and we can find the corresponding years of experience they might have. So this is the important application of this line. So this model is called as a linear regression, where we try to fit the data points to a normal straight line. Okay. So the application of this is we can find the y value given the x value. Here, x is the independent value, and y is the dependent value, because the value of y depends on the value of x. Okay, so hence x-axis value or the years of experience is the independent value, and salary in rupees per year is a dependent value, because most of the time the person's salary will be based on the experience that they have, right? So this is one main thing that you can do. There is also another way where you can try to find this particular value or particular thing. So this is how machine learning model works, as I have told you before. So a machine learning model tries to learn from this data. Here this normal line has found the trend between the data, that there is a linear relationship between them, and if one value increases, the other value also increases. And this is how machine learning model works. They try to fit to this particular data set to find the trend between them. So this is how you can find this particular value graphically. And now let's try another method where we can find the equation of this line, and we can find the similar values. So now let's say that we have different set of values. So we have x-axis value and y-axis value, and the if the value of x is 1, then the value of y is 5, and the value of x is 2, the value of y is 7, and so on. And the value of y depends on the value of x. So y will be the dependent value, and x will be the independent value, and whatever the value of y is, it is dependent on the value of x. Okay, so now let's again try to fit this in a graph. Okay, so we have plotted the data points in a graph. So we have x-axis values in the x-axis and y values in the y-axis. Okay, and let's try to plot these values. So 1 comma 5, the coordinate 1 comma 5. So the x-axis value is 1 and the y-axis value is 5, and we will get the plot here. And the second data point is 2 comma 7. So 2 comma 7 will be here, where the x-axis value is 2 and the y-axis value is 7, and so on. So totally we have about 5 data points. Now let's try to fit this data points to a curve. In this case also, we can say that we can use a simple straight line in order to fit all these data points, right? So you don't need to use a very complex model. You just need a straight line to fit all these data points. Okay, so now we need to find the equation of this line. So from our primary school, we have studied that the equation of a line is y is equal to mx plus c. Okay, right? So we would have studied this in our high school. So it is very simple equation. So y is equal to mx plus c, where m is the slope of the line. So x represents the x-axis value, y represents the y-axis value, and m represents the slope of the line, and c represents the intercept. Okay, so let's understand about the slope and intercept in the next slide. So I'll explain you how this slope and the intercept works, but just try to understand that this is the equation of a line, which is y is equal to mx plus c. Okay, so different lines will have different values of m and c, and based on these values of m and c, y value depends on the value of x. Okay, so if you have a value of x, and if you plug the value of x in this particular equation, you will get the value of y. Now let's try to see how we can find the value of this particular slope and intercept. Okay, and then we can try to find the equation, the actual equation of this particular line. So this is the general equation of a line, and we need to find the specific equation for this particular line. Okay, so let's try to do that. So we have the plot here, and this is the line that joins all these data points, and we know that the general equation of a straight line is y is equal to mx plus c, where y is the y-axis value and x represents the x-axis value, and m represents the slope and c represents the intercept. So now let's try to find the values of m and c. So m represents the slope. Slope represents the orientation of the line in this graph. So if you have a different slope, so what happens is, so I'll just show this in the previous slide. So if you have a different slope, your line would look something like this. Okay, so the slope of, so consider this is a straight line. So the slope of this line is different, and the slope of this particular line is different, and the slope of this line is different from this one. And if you consider the slope of this particular line, this is different. So the slope basically represents the orientation of the line. Okay, so this line has some particular orientation, and it depends on the slope of the line. And now we have the intercept. Okay, so I'll just remove this. So you just need to understand that slope, if you change the slope of a line, then its orientation changes. So that's what you need to understand. And what is this intercept? So you can see that there is a difference between the origin. Okay, so this is the point where the line is starting, and this is the origin, right? And this particular distance is called as the intercept of the line. Okay, so this distance, so you can see that this distance is 3, right? So if you just look at this y-axis value, so 0, 2, and 4. So between 2 and 4, we have 3. So the intercept value or the C value is 3. So intercept value is the distance between this origin and from where the line is starting. Okay. So now let's try to find the value of M and C, the slope and intercept, based on the data points that we have. Okay. So the data points that we add are these values. So 1 comma 5, 2 comma 7, 3 comma 9, 4 comma 11, and 5 comma 13. So these are the data points that we have, and based on these data points we are going to find the values of M and C. So let's take 2 points, two data points, p1 and p2. Let p1 be this second data point, which is 2 comma 7. So the x-axis value is 2 and the y-axis value is 7, and the second point is 3 comma 9. So this is the, let's take this as p2 or the point 2, and this is 3 comma 9, where the x-axis value is 3 and the y-axis value is 9. And there is a formula to find the slope of a line or the orientation of this line. So the slope formula is m is equal to y2 minus y1 divided by x2 minus x1. Okay, so here we know that the point 2 is p2 and the point 1 is p1. So we need to take the later point as p2 and the smaller point as p1. So this will be our point p2 and this will be our point p1. Okay, so now this 2 represents the value x1. So just look at this formula. So we have x1, x2, and y1, y2. Here 2 represents x1 and 7 represents y1, and 3 represents x2 and 9 represents y2, right? So you understand this, right? So p1 represents the values x1 comma y1, and p2 represents the coordinates x2 comma y2. Now you need to substitute these values. So this is the formula for slope, which is y2 minus y1 divided by x2 minus x1. Now we need to substitute the values. As I have told you, 9 is y2 and 7 is y1. So it is 9 minus 7 divided by x2 is 3 and x1 is 2. So we just need to substitute the values here. Now it will be 9 minus 7 is 2 and 3 minus 2 is 1. So you will get the slope value as 2. So it will be 2 divided by 1, which is equal to 2. So the slope of this line is 1, sorry, 2. So what does this slope represent? So it represents that for if the x-axis value changes by a unit of 1, then y-axis value will change by a unit of 2. So that's the importance of slope. If the x-axis value is 213, so there is an increase in the value of x, right, by a value of 1, and for each increase in value of x by a factor of 1, the y-axis value will increase by a factor of 2, as you can see here. So if we increase the value of x by 1, so we are just adding 1 to this data point 2, and you will get a value as 3, right? And similarly, when you add the value 1, you will get the slope value or the y-axis value by the value will be added by the value of 2. So that is meant by this slope. So I'll just explain you this in a different manner. But before that, let's try to understand the intercept of this line. So we found the slope of the line to be 2, which is m is equal to 2. And now we need to find the intercept of the line. So I'm just taking another point 4 comma 11. So I'm taking this fourth point, which is 4 comma 11, where the x-axis value is 4 and the y-axis value is 11. Okay, so now we need to substitute in this particular equation. So we found the value of the slope to be 2, so I've just substituted the value of m as 2 in this equation. So y is equal to 2x plus c, and we need to substitute the values of x and y. So we know that the value of x is 4 and the value of y is 11. Now, if you substitute all the values, so 11 is equal to 2 into 4 plus c, you will get the value of intercept as 3. So it is nothing but c is equal to 11 minus 8. So you will get the intercept value as 3. So which we have seen in the previous case as well. So as you can see here, so we found the intercept to be 3, right, graphically, and we have found using these equations and these formulas that the value of intercept is 3 and the value of slope is 2. So we can write this equation of this line here. So we found the equation to be y is equal to 2x plus 3, because we know that the value of slope is 2 and the value of intercept is 3. Okay, so you can take any 2 points. It is not compulsory that you need to take these 2 points. So you can take this particular first point and you can take this fourth point, and in that case also you will get the value of the slope as 2. Okay, so this particular line represents the slope. So this triangular part represents the slope, and you can also represent this slope as y is equal to dy by dx. So we know that this is nothing but the differential equation, right? So dy by dx. So dy means change in y and dx means change in x. Okay, so you understand that, right? So dy is the change of y and dx is the change of x, and dy by dx represents what is the change of y when x changes. So from this, we have found that if the value of x changes by a value of 1, then y will change by a value of 2. So that is the value of, this same, which is equal to 2. So you can also consider this. So if dx is 1, then dy will be 2, which represents the slope of the line. So the important so the another factor which we have discussed about is the intercept. So c represents intercept from where the line starts, right? So if you have the intercept as 4, then your line will start from this point 4. If you have the intercept as 7, your line will start from here. So in this case, we have an intercept of 3, and hence it starts from here. So the important inference that we are getting here is the above line equation is a function that relates x and y, right? So we get an equation, and this equation relates x and y. Okay, and for a given value of x, we can find the corresponding value of y. So similarly, let's say that we have a value of 3.5, and if you just draw a dotted line here and see where this line joins, and the corresponding value will be the value of y when your x value is 3. So this is the same thing which we have done with the years of experience and the salary example. So we try to find the salary of a person with 3 years of experience, right? So similarly, for a given value of x, you can find the given value of y. So this is machine learning. So machine learning is very simple, so you don't need to complicate things. So we are just trying to fit a curve or a line to a data, and we are trying to find the corresponding y value. So this is all about machine learning. So the only difference is that in all the cases we cannot use a straight line, so we may use a very complex model. So line is also a model. So this is a linear model, and we call this as a linear regression. So similarly, you can have a polynomial model and different kinds of models. So the model changes, but the concept remains same. Okay, so this is how a linear regression works, where we have two sets of data, the x value and y value. So we cannot have more number of dimensions. So we can have only one x value and one y value. So in that case, you can use a simple linear regression model or a simple line in order to fit those data to a straight line. Okay, and once you do that, your machine learning model or your linear regression model will learn from the data, and you can use this learned model in order to make new predictions. Okay, so this is all about linear regression, and this is how linear regression works. So now there is also a few other things which I need to explain you. What if there are more than two variables? So in the previous case, we have x value and y value. So we have two variables which are x value, x variable, and y variable, right? And I have told you that x is the independent variable and y is the dependent variable because the value of y depends on the value of x. Now, what if there are more than two variables? What if there are more than two independent variables? So in that case, what you will do is you will use a multiple linear regression. So this is an example for a simple linear regression where we just have two variables, and the multiple linear regression is one where you will have more variables. So this is the definition of a multiple linear regression. So multiple linear regression is a model for predicting the value of one dependent variable based on two or more independent variables. Let's try to understand this. In the previous example of salary and years of experience, we just considered one variable, right? So the one variable here is years of experience, and the dependent variable is salary. Now, what if the salary of a person not only depends on the year of experience, but it also depends on his educational qualification? Let's say that the salary of a person depends on both the years of experience and what degree he has studied. So let's say that one person has studied B.Tech, so he has studied Bachelor of Engineering or Bachelor of Technology in Computer Science, and there is another person who has studied Master of Technology in Computer Science or Master of Engineering in Computer Science, and both of these people are 2 years of experience. So one person has studied BE Computer Science, and the another person has studied ME Computer Science, but both of them have 2 years of experience. Now we can logically say that the person who has completed ME with 2 years of experience will get a more salary, right? So in this case, there are three variables. So the one variable, the dependent variable, is salary, and the other two independent variables are years of experience and their educational qualification. In that case, you will need to use a three-dimensional model. Okay, so this is the example of a multiple linear regression. So this is not a line anymore. This is a plane, and if you want to be more accurate, this is called as a hyperplane. Okay, so when you have more than two variables, in that case you will be using multiple linear regression where it tries to fit to the data by means of a plane. Okay, so you can consider this one axis as salary, and this axis to be the number of years of experience, and this line represents the qualification, educational qualification of that person. Okay, so this is how the equation of the line looks. So this is the equation of a simple linear regression, which is, this is just the similar to y is equal to mx plus c, where instead of m we have represented b1, and instead of x we have represented x1, and b naught is nothing but the intercept c. So y is equal to c plus mx. So it is similar to that equation of a simple line, and this is the equation of a multiple linear regression where b naught is similarly the intercept, and x1 is the one variable and x2 is the another variable. So similarly, you can have any number of variables you want. So often in machine learning, the data set that we have will about tens of features or even hundreds of features. So in that case, you can use a multiple linear regression where we have multiple number of features, and in that case we have multiple number of parameters. Okay, so the only difference is that you can use a simple linear regression, a straight line, when you have one dependent variable and one independent variable. And in case if you have one dependent variable y and there are multiple independent variables as x1, x2, x3, etc., and in that case you will use a multiple linear regression. Okay, so this is the difference between a simple linear regression and a multiple linear regression. And finally, let's try to understand about what are the advantages and disadvantages of this linear regression model. So linear regression is model is very simple to implement. So we don't need a lot of features. So we use linear regression when we have only two features. So we don't need a lot of parameters. We just need the value of the slope and the intercept. So that is enough for us. So that is one main advantage. So it is very simple to understand and implement. And the second advantage of linear regression is it performs well on data with linear relationship. So we have discussed an example where we tried to find the salary of a person based on the years of experience, and there is a linear relationship between them, which is if the x value increases, the y value also increases. So in that case, you can use a very simple linear regression. So you don't need to use a very complex machine learning model like random forest, or you don't need to use a very complex deep neural network in order to find this particular relationship. You can just use a simple line when there is a linear relationship between them. So these are the two main advantages when it comes to linear regression. And there are also some disadvantages to it. So as this model is very simple and it it is not suitable for data having non-linear relationship. Okay, so let's say that we have data something like this. So here you can see that this data is in the form of a sine curve, right? So there is an increase in the value of the data points, and then there is a decrease in the value, and again there is an increase and so on. So here we have the value as t. So this can be time and this can be the y value, or you can just consider this as x value. So what happens here is when the value of x increases, the value of y first increases then decreases, and when the value of x further increases, the value of y increases and it again decreases. So this is an example of a sine curve, and this is not a linear relationship. So this is a non-linear relationship, and to be precise, this is a sine relationship between t and y or x and y. So you cannot use a straight line in order to fit this particular data. So no matter what line you have, you cannot fit all these data points to a straight line. So you cannot use a linear regression to the data points which does not have a non-linear relationship, and that is one main disadvantage. Okay, so a lot of real life problems, a lot of real life data won't be linear, so there will be a more complex relationship between them. So in those cases you cannot use a linear regression. And another disadvantage is there will be a lot of underfitting issues in the case of linear regression. So we know that underfitting is something where a model cannot find the pattern present in this data, because a model is very simple, very general. So it leads to underfitting issues. So if you are not sure about underfitting, just go to my sixth module, and that module is on machine learning models, and that I have explained about what is meant by this underfitting and how you can rectify this underfitting. So you can watch that video. For now, I'll say that underfitting is when your model doesn't fit to your data better. Okay, so there is a lot of bias in your data. So that is called as underfitting, and linear regression often leads to this underfitting issue where it fails to find the relationship between the data. Okay, so that is example of an underfitting. So let's try to fit a straight line to this sine relationship. I'll explain you about underfitting here. Let's say that we are just drawing a horizontal line. Okay, so now we call this straight line as an underfitted model because it doesn't fit this data in a proper way. Okay, so hence we call this as an underfitted model, and there is a high chance that linear regression model will underfit. Okay, so that is one main disadvantage. And finally, sensitive to outliers. So when there are a lot of outliers, your linear regression model will be very sensitive to it. So outlier is nothing but when, let's say that there are about 10 data points, and out of these 10 data points, 8 data points are similar. Okay, so whereas the two data points are not similar to each other. Like if you consider this particular example, so there is some trend in this data. And what if there are points like this? So there is a point here and there is a point here. So this data doesn't represent other data well, right? So these are outliers, or these are noise in the data. And when there are outliers and noise in your data, and your linear regression model will change, the parameters will change based on those outliers. So when you have a lot of outliers in your data, and it is not very suitable for you to implement a linear regression model. Okay, so that's another thing which you need to keep in your mind. So the reason or I'm explaining this advantages and disadvantages is that you need to weigh all those advantages and disadvantages when you are choosing a model. So let's say that you have a data set and you need to find which model suits better. So if there is a linear relationship between the model, and if there is a linear relationship between the data points, and the data point doesn't have a lot of outliers, in that case you can go with a simple linear regression model. So you need to understand the advantages and disadvantages of all the models in order to make a better model selection. Okay, so you need to understand the advantages and disadvantages for that particular decision. Okay, so that's it about linear regression model, and I hope you have understood all the concepts about how a linear regression model works, how it fits to the data, and the two parameters which are the slope and intercept. And I hope you have understood about multiple linear regression which we use when we have multiple parameters, and I hope you have understood all the advantages and disadvantages of linear regression. So that's it for this video, and I'll see you in the next upload. Thanks for watching.